Vanakkam. Welcome to this course on classics in neuroscience. We have been looking at the topic of theoretical neuroscience, how we can consider the brain as a computer and how we can consider the computer as a brain. In this video, we will look at two topics. First is the work of Norbert Wiener in single-handedly introducing this field of cybernetics, and the rise in the 1940s and 1950s of this exciting field of artificial intelligence. Norbert Wiener was the son of a Harvard professor. He did not go to school, he was mostly homeschooled, and he graduated high school at 11 years or 12 years and graduated from I think from Tufts at 14 years, if I am right. He got a PhD from Harvard University at the age of 18 in mathematical logic, and due to his views or ethical grounds, he did not join the Manhattan Project. So, he himself decided to work on other topics such as ballistics and communication theory. In particular, he wanted to work on control theory, specifically on feedback loops to control the output of a system at some desired set point. The question is, how are this related to human behavior or brain function? Because there are many cases where this is useful, and he himself had many people who inspired him. The logical calculus and the work of logical calculus by McCulloch and Pitts, the autonomous robots of Gray Walter, and also the state of the art in the fields of neurophysiology and neuroanatomy. Wiener practically invented the term cybernetics to mean steersman. He called it cybernetics or control and communication in the animal and the machine. So, it's a weird topic even now, but in the 1940s, 50s when he introduced, must have been something that's straight out of a sci-fi movie types. So, he introduced this, he practically coined and invented this term cybernetics. So, there were several seminars and meetings that were happening frequently in the Boston area that was frequented by giants like Norbert Wiener, Derek Denny Brown and others, exchanging ideas about cybernetics. Meanwhile, Wiener speculated on correlations between the alpha rhythm in EEG and intelligence. However, his own experiments did not confirm this hypothesis. That is, if someone is having more alpha rhythms, for example, they will be more intelligent types. Obviously, it is not that trivial. So, that kind of information perhaps is a little deeper, it cannot be so simply correlated with just raw EEG, for example. Perhaps it was a lot more deeper. Meanwhile, works on autocorrelations, cross correlations of cortical potentials and cardiac rhythms. Some experiments, related experiments were conducted at MIT by some giants. A lot of people were working on this topic. Meanwhile, there was this crucial problem of how do you get reliable brains from unreliable neurons, was a question that John von Neumann asked, and people were breaking their head over how is it possible that the foundations, the fundamental units are so unreliable, yet the brains are a lot more reliable. How is that possible? So, the fundamental ideas of cybernetics and control theory are proposed to be systems that sense inputs that generate and then generate outputs to achieve certain goals, and then adjust actions based on feedback. The central concepts included error signals that are generated as the difference between an intended output versus the actual output, for example, self organization, self reproduction, and most importantly, goal directed behavior, very critical, goal directed behavior. Yes. Obviously, if these are the central tenets of this theory, then this theory may also be applicable to improve our understanding of brain and dynamical systems within the brain. So, this gave insights into functioning of complex systems. A lot of people meanwhile were interested in understanding how information is handled by humans and how to mimic this to design machines that simulate human ability to handle information. A lot of conferences, these conferences came to be called as the Macy conferences, conferences on circular, causal and feedback mechanisms in biological and social systems, and a lot of different topics were covered: goal directed behavior or goal directed activity, signal communication, neural networks, neural nets, closed cortical loops of Laurent Dino, for example, economics, psychiatry, reverberating and context addressable memory, learning theory, like essentially the entire breadth. And if you look at the list of attendees, you will see some giants: Laurent Dino, Warren McCulloch, Linus Pauling, Claude Shannon, John von Neumann, Norbert Wiener. Practically everybody is a giant. So, these conferences together started building this field of attempting to mimic or imitate human intelligence. This came to be called as artificial intelligence. From 1950s, or at least in 1950s, this was an exciting topic. The idea that machines could think like humans. Even today, this is an exciting topic. So, or maybe it regained its prominence once again after going dull for some decades, open to debate. But now also artificial intelligence is an exciting topic. It was so in the 1950s also. Meanwhile, Pitts and McCulloch published another paper in which they ask how we know universals, the perception of visual and auditory forms. There they address the problem of how to produce invariant recognition of a pattern despite distortions. So, there are some distortions. Despite that, how to recognize a pattern. This started a whole new field, which is a crucial field called as pattern recognition, the ability to recognize patterns. In 1954, A. Motley came up with this neural nets that had activity dependent modifiable synaptic connections that can learn binary stimulus patterns that essentially drew from the ideas of Donald Hebb, Hebbian learning. Then others, B.G. Cragg and H.N.V. Temperley, used the spin glass to simulate the properties of spinning atoms in a ferromagnetic substance. These atoms could orient up or down based on interactions with neighbors, similar to neurons being on or off based on interaction. So, maybe this could also help us understand neuronal function. Also, R.L. Burley worked on stable neural patterns and memory-like functions in 1956. All these works essentially established this new field called artificial intelligence in early 1950s. One of the early attempts of relevance to the nervous system or to neuroscience, the application of artificial intelligence and pattern recognition to the field of neuroscience may be the perceptron of Frank Rosenblatt that was proposed in 1958. Essentially, McCulloch-Pitts net with modifiable connections that could be trained by repeated exposures to learn to discriminate between different patterns. This consisted of a single layer of nodes that represented the neurons, connections that are adjusted according to their appropriate activity. So, depending on the input, whatever is the output. So, there was this input, and there was this transfer function, and then there was an output. So, each of this neuron had some transfer function, for example, appropriate activity that represented the. So, essentially the connections that are adjusted according to the inputs and activity and their response to a given stimulus. A similar system was described by Widrow and Hoff that they called as ADALIN. It's called as an adaptive linear neuron. Now, we have a whole bunch of these kind of neurons, and we still continue to use Rosenblatt's perceptron in some of the analysis. So, again showing how theory and the fields of artificial intelligence and these advanced fields and the developments of the 1950s was crucial to build theory for themselves, theory for computation and theory for computer science, but also to improve our understanding of the central nervous system of neuroscience as a field also. So, something to keep in mind. With this, we come to the end of this video. In this video, we looked at cybernetics and artificial intelligence, the contributions of Norbert Wiener in single-handedly coming up with the field of cybernetics and artificial intelligence, the developments in the 1940s and the 1950s that led to this exciting new topic of artificial intelligence in the 1950s that continues to be an exciting topic even today. With this, we end this video. Thank you for your attention.